It's about time. Really. Like, I have to remember everything, lady. You should just kick in. You should just know by now. All right, sorry. It's been a bad technology day for me. I'm gonna erase this. Has everybody got this? You should have some version of that copied down. Okay. Let me erase this. What I'm about to show you is nothing amazing. Holy shit, Jeff, that's not, I'm using the wrong eraser. There you go, buddy. Just continue the theme of the day, which is Jeff is old, can't do technology. Is there a way to make a bigger eraser with this shit?
I'm pretty sure if you if you use like the text box, like you can delete it all in one shot.
Text box. I don't think I can do that on a PDF, or if I can, I don't know how to. Boop, boop, boop. I'm there. All right. Yay. Real quick. This is almost going to be silly now. I don't even know if anyone's going to appreciate this, but do you see how there's a 1 minus cosine x here? So if I'm really, really stumped, I'm going to do this. I'm going to multiply top and bottom of this by 1 minus cosine x. Because I know that is supposed to become something that has a 1 minus cosine x on the bottom. Will this always work? No. Is this always the best way to do it? No. So why am I showing it to you? Because the more you know you can do, the more you can try if you're stumped. So what happens on the top here? I'm going to just bear with me for a little bit. 1 minus cosine x. All right, let's do plus secant x minus cosine x minus, now what is secant times cosine? You could do it. They're what's of each other. Secant is the what? Say again?
Isn't it the reciprocal of cosine?
The reciprocal. So when I multiply, I get 1. So it'll be minus 1. So those cancel. Is that cool? All over secant x times 1 minus cosine x. I don't want to mess with this guy because that's the whole purpose. I want him there. I have no idea. If you don't understand what I'm doing right now, don't worry about it. You don't have to ever do it this way. Never. There's always another way. But this is kind of neat. Now, so that means that if I just divide the top by that, I have to be there. I have to, because then the bottom has got what it's supposed to have. So secant divided by secant is 1. What is cosine divided by secant? That's cosine divided by 1 over cosine, so it's cosine times cosine. So it's cosine squared. And then what's 1 minus cosine squared? Sine squared, and I'm done. So in this case, it actually happened to be quicker, but trust me, this way does not always work. It's not, sometimes not nearly as pretty, and sometimes it just doesn't work. But it's another thing to try. Okay. So hopefully you're picking up on a couple of general things. So breaking it down to sine and cosine is not a bad idea if you really don't see anything else to do. I do want to show you, I want to make sure you guys see something in the first way we did it. Can you guys see that 1 over secant is cosine and secant over secant is 1? So that just becomes cosine x plus 1 right away. Is that right? Okay. So you don't always have to take it to sine and cosine. You do not always have to do that. You can work with it as it is. If you don't see what the hell to do, then putting in terms of cosine and sine might show you some stuff to try. All right, just want you to really get what you're allowed to do here, because you're not going to try it if you don't even know you can. All right, Jeff, just keep going. What about part C? Go ahead and try part C if you haven't tried that out yet. That's got the newer identities in it. This might be a bad side to start with. But, you know, maybe not. Let me see. Would it work? That's gross. I don't think that's gonna work. Oh, that's interesting. Maybe it will work. Let's see. Ha ha ha. Yeah. Neat. Sorry. Yeah, I still enjoy this shit. I do. I play video games instead of doing trig identities if I'm bored. So I'm not quite that far gone, but I still get a kick out of doing these. I think I'm going to do this on the board. I just don't like having not enough room here. All right, stop sharing. Oh shit. Where'd you go? No, come back. There you are. Not you. This thing. Okay. So you got sine 2x over 1 plus cosine 2x plus tangent x. Okay. Somebody have something they tried. Oops. Let me make this so you can see everything. Somebody else I haven't heard from yet. Does anybody have something they're trying? You don't even have to have gotten anywhere with it yet. Is there something you're trying to make work? Anybody? Hello, hello. Is there anybody?
I made sine 2x 1 minus cosine 2x.
Oh, be very careful. I appreciate this. It's sine squared plus cosine squared. So you got to be careful. There's no rule about sine 2x and cosine 2x doing anything specific together. Does that make sense? So be very careful. It's sine squared that combines with cosine squared to make 1. So did this one stump everybody? Or maybe people that have already spoken have done something, but all right, so let me see. So watch this. Some of my trig functions are in terms of double x, and one of them is in terms of x. So obviously I've got to convert. There's no way that this can equal that unless I can make all this in terms of x. Does that make sense? That is a general rule. And that's, if you notice that some of it's in half angles or some shit, then obviously you want to use that identity, make them all the same angle. There's no way they can equal each other otherwise. So what's the identity for sine 2x?
Two sine x cosine x.
And now down here, this is where things get weird. I have several different versions of cosine 2x. And this guy is a little bit sucky for that. I could either use cosine squared minus sine squared. I could use 1 minus 2 sine squared. Or I could use 2 cosine squared minus 1. And you guys are probably like, oh my God. You might have picked up that when you have more than one option, it kind of sucks. Does anyone see what might be a really, really good option to pick considering what else is there? I want him to die, don't I? Don't I want that one to die? Because there's none of that shit over. There's nothing on the bottom here.
Yeah, so 2 cosine squared minus 1.
Yes. So if I replace cosine 2x with this, the ones will kill each other. I love it. So again, I keep trying to throw at you different reasons you pick a certain thing or different things you're able to do. Okay, so I'm going to replace cosine 2x with 2 cosine squared x minus 1. Die. So now what happens? Jeff, you could write the whole thing. All right, Jeff. We're almost there now, right? The 2's die. One of the cosines die. And what's sine x over cosine x?
Tangent.
Tangent. And now, yeah, we didn't even have to work on that. There was really nothing to do on that side. As I say that, I'm about to show you a different way to do this. And again, don't freak out if you didn't think to do that, because right now we are getting used to what we're able to do. What do we have flexibility with? What am I allowed to do? What should I look for? You don't know none of that shit yet. So let me show you. I keep pushing this way because I got excited that it actually worked here because I didn't think it would. At least not pretty. So everybody got this here? Anybody not got this here? Okay. So here's what crazy ass Jeff tried to do. Probably what he's been saying to do all the time. I started on that side. What I did was I multiplied top and bottom by 1 plus cosine 2x. Because I know it's supposed to have one. And this is where I lost a little faith, right? I was like, I don't know about this shit. Then what did I do? I can't even remember what I did. Oh yeah, okay, so this is where things get cool. So if I bring this through, all right, I think that's everything, right? Yes. Cool, I like it. Now if I replace this with 2 cosine squared minus 1, if I were you, I would never do it this way. All right, I just want to show you this, and this is weird as shit, but I understand that you would never do it this way. Now watch. So I'm going to do it up here. So then I get tangent x plus 2 tangent x cosine squared x minus tangent x. Right? If I distribute that. Stay with me now. Stay with me now. Come on, come on. This is gross. It's already taken longer than the other way, and I don't care. What's tangent x times cosine x? Isn't this, did I do this right? Yeah, I did. All right, Jeff, what the hell? Sine over cosine. So one of the cosines cancels. So it'll be tangent x plus 2. So a cosine cancels the cosine. So there's a sine from the top of tangent left, and one of the cosines are left. That looks interesting. And then these kill each other. And what is 2 sine x cosine x? It's sine 2x. Done. Freaky. And I really want you, all right, I'm sorry. I get excited. I kind of like that you guys get to see things happen. Like I didn't do that ahead of time, right? I just tried it right now as I gave you the problem. So I don't even know what's going to work. So it's not like you suddenly know exactly what's going to work if you get enough math in your head. Nope, sorry. That's not going to happen. You just have more of an idea of what to look for. You have more of an idea what could probably work than something else. You know what flexibility you got. You know what you can try. That's all it is. It's not me looking at a problem knowing exactly what to do. It's me looking at a problem and knowing exactly what to try. right? That's the difference. And I could try something that doesn't do shit, and somebody else could do it faster than me, and I don't care. Just because it's a little bit of luck too. If you happen to pick the way that makes it fast, all right, good for you. Let's see what we do on the next problem. All right. Let's see what time we got. Okay, this is fine. These identities are weird, so I don't mind spending a little bit of time on them. I'm hoping you're picking up more stuff here. Let's try this next one. Let me see. Does anybody need me to share this? Let me know. You want to try part D? I want you to try problem D. Oh man, I'm down to one person and 19 boxes. Are there any other people out there that could turn on their camera? If you can't, I understand. It's fine. No? Okay. Oh, thank you, Emily. All right. It does help my mental health, and you want. I'm not the most stable genius. Not like certain people up in government, but this helps maintain whatever level of stability I have if I can see people. Let me just ask you guys, what is the most obvious thing to try on this problem? Or is there an obvious thing? Is it completely not obvious? I mean, what is there to do on this side?
You have to get rid of the ones in the denominator, and then you have 2 secant.
How do you mean get rid of the ones?
Yeah, that's where I'm looking at it. I don't know how to get rid of the ones.
Oh, what's on this side? There are 2 whats? There are 2 fractions, aren't there? And they're adding. So, I mean, what do you do when you add fractions? You put them together. You get like denominators. Does anybody with me? So if I see, like this problem, 2 separate fractions equals 1 term, I'm going to put those fractions together, right? Again, even if you're not explicitly using the thing that I keep doing, making something show up that's in the result. I don't know if you guys know what I'm talking about. What I keep doing, trying to make the what I have look like what it's supposed to be in some place, right? You're always kind of doing that. There are 2 terms on one side, 1 term on the other. So let's make that side 1 term. How do I do that? Like denominators, right? Am I saying that's the only way to do this problem? Nope, I'm not saying that at all. I'm saying that's the most immediately obvious way to do this problem. So how do I get like denominators? What does this first dude need?
1 plus sine x.
Exactly. They're missing each other. Oh, so he needs him and he needs him. Oh, he's so nice. Of course, I got to do it on the bottom also. Come on, Jeff. Bam. And you got to put a 1 in there first. Dadgummit. Bam. So on the top, I get 1 plus sine x plus 1 minus sine x all over 1 plus sine x times 1 minus sine x. So what happens on the top that's interesting? What happens on the top?
The sine of x cancel each other out.
Good. And I get that 2. I get that 2. That's cool. It's always nice to see a piece of the other side showing up out of nowhere. There's a 2. And then on the bottom, what can I do with this, of course? These things.
It becomes 1 minus sine x squared.
Yeah, these are like, what do I call them? Difference of squares buddies is what I call them, right? If you multiply the shit out, FOIL it out, the middle terms cancel. And of course, 1 minus sine squared is
Cosine squared x.
cosine squared, and 1 over cosine squared is secant squared. So there's another general approach you can use when I see two separate fractions, and on the other side is just one term. I'm going to put the fractions together. Of course I am. Did anyone do it a different way? If you did, that's a way I didn't even think of, which has got me curious. No? Okay. All right. Let's try one more, and then we'll call it a day. This also uses a semi-new identity, right? Right there. So I gave a big hint about where to start on this problem. Is that the only way you can do it? No, but it's the easiest way to do this problem. I'll tell you that right now.
Wouldn't it be the same thing as the bottom?
Definitely not, right?
Oh, cosine.
Let me pull this dude over here. Where is he? Here he is.
Cosine x.
If I put that there, can you see it? Can you see the laws again? Everybody? Anybody?
Yeah, you can see it.
Okay, thank you. Help your old teacher out. All right. So cosine x plus y is going to equal cosine, cosine, sine, sine. Yeah. But that's immediately going to lead somewhere interesting. So I can replace cosine x plus y. It's a cosine. It's an asshole. Me first, me first. That's a plus, so cosine's an asshole. I'm going to make it a minus. And now you get a turn sign. And now, of course, why can't I just cross those signs? Why can't I just cross these signs out?
Subtraction on top.
Yeah, thank you. So, but I can, and notice something else. Aren't there two terms on this side? So that kind of tells me I want to split this shit up, right? So I got cosine x, cosine y, over cosine x, sine y, minus sine x, sine y. Wow, I'm really like trying my best to write as horrible as I can. I hope you appreciate that. And then the cosines cancel and the sine y's cancel, and I get cosine over sine of y is what? Cosine over sine.
Tangent of y.
Cotangent. You basically can look here, right? We're there. Minus sine x over cosine x is tangent x. So one thing I want to point out is these are the basic rules. If you memorize these, and in fact, some of these you can memorize and then not have to memorize other things like the Pythagorean stuff. But if you memorize these, you can create these. And in fact, if you memorize these, you can create this identity, you can create this identity. I mean, we just did. So how many true trig identities are there? Okay, there's a lot. How many do we have to know? Green sheet, right? Because they can be used to create or verify other trig identities. Are any of these useful? I don't know. Could be useful somewhere. You never know. These are the ones that are most immediately useful. These might have some very specific uses in some branch of physics. Who knows, right? Never know. All right. How do you guys feel? That's enough, right? That's enough for today? Yeah, I think so. So don't forget, oh, by the way, you might want to remind me for this. I did put the practice quiz up, but I haven't done the solution video yet. So feel free to email me and remind me to do that if you want to. It should happen, but email is not a bad idea. What else did I want to say? Oh, that was what else I want to say. Don't forget the quiz on Monday. So there you go. That's a twofer right there in that announcement. If you need to hang out, let me know if you have any questions. Otherwise, you are free to go. I am watching the debate. I have my favorite YouTube commentator paused at the moment that I'm going to go to after class, and he helps me watch the debate because he kind of fact checks shit as it happens and makes fun of some stuff. So it's always nice to watch it with some help, either that or wine or both. Yeah.
Professor.
Yes.
So I sent you a message about next week because I'm
Okay.
going out of town. I don't know if you got it or not. I just wanted to let you know that I'm planning on still being able to attend lectures, but just in case something happens.
Oh, that's right. I remember now. You're going to be out, but you're going to still try to attend. Yeah, that's fine. That's on you if you can get there. If not, I put the videos up right on YouTube, but do try to attend if you can. Yeah.
Okay, I will. Thank you.
Sure. All right, guys, I'm out of here.